In this example, we're going to be comparing some different variables together. We can only compare two of them at a time together though. And so if we take a look here at the data, you can see that we've got waist, weight, and body fat. And actually this section would be just a continuation of this table. It's very important that the first number is the first number for each list. The second number is the same one because this corresponds to the same person. You wouldn't want to do 32, 175, and 21 because you'd be switching people. Now I've entered my data in already. To enter your data in, just hit the STAT button right here and then just enter and you'll go to the edit function. You can see also that my values in each one, the number of values, are the same. If we cursor over the last one, it says the 20th one in list 3 is 28, and you can see everything below that is blank. They all end on the same one. Your calculator will not like it if you ask it to compare 20 items to 21. It doesn't know what to do. So it'll say something like dimension mismatch, dim mismatch. Let's see if we can work with this data though. So take the time, hit pause if you need to, enter this data in, and make sure that you have the same number of data. We have some questions to answer with this one though. And so we're going to take a look, we're going to graph a scatter plot, and in this case it's going to be, pardon the interruption here, it's going to be, the first one will be waist size versus body fat percentage. Now remember, waist size was in list 1 and body fat percentage was in list 3. It's important to remember which of those you have entered in and where. So let's go to our calculator, and what we're going to do is we're going to hit second here and y equals. That'll get us to our stat plot. I'm going to hit enter. My statistics plot is already turned on. Notice that the on is highlighted. So if you want to turn it on, when the cursor, the blinking cursor is over that position, just hit enter. If I hit enter, it'll turn it off. See, it won't turn it off if I turn it off by cursoring over and hitting enter, but I can turn it back on just by cursoring over and hitting enter. Now the type here, mine's set on a histogram right now, but we want that scatter plot. It's the first one. A few things just changed. There used to be just an X list, and now there's an X and a Y list. We need to make sure that the X and the Y list, though, are where our data is entered in. And so list 1 is the weight size, but list 3. So I'm going to hit second and the number 3, and that'll get me to L3. The mark can be anything you want. I like just the square. You can do a plus sign or crosshairs if you want, and then there's like a little point right there. So you choose. Now that we've set everything up, we're going to ask the calculator for a nice viewing window. So I'm going to hit zoom and then number 9. And zoom 9 will give us a nice look at this data. And so it seems like things are fairly close together for waist size and body fat. But what I mean by that is if I drew a straight line here, it would seem like most of the points are close to it, and it would also seem as your waist size goes up, your body fat percentage goes up as well. So remember, the X variable here was list 1, which is waist size, and then body fat is on the Y-axis over here. So as your waist size goes up, also your body fat percentage goes up. Let's take a look at the second one, and I want you to try to remember what this looked like. It's going to be kind of tough. We're going to graph a scatter plot now with weight, which we entered in list 2, versus body fat, which is still list 3. So this is very easy in your calculator to adjust this. We just need to hit second and y equals, go to our statistics plot 1. It's already on the right thing, scatter plot, or right type of graph, and so all we need to do is change our X list. So we'll hit second and then just hit a number 2, and that'll pop in L2 or list 2 there. And then all we need to do is hit zoom 9 again. So we get zoom 9, and here is the scatter plot of that data. If we drew a straight line here, it looks like as the X goes up, or as weight goes up, also your body fat percentage tends to go up as well. The question is though, it says like number 3 here, we've been kind of describing this verbally. Number 3 says, now that you see the graphs, what do you think is more closely related? In the question here is, in which graph, if you were to draw a straight line, in which graph were the values closer to the line? Where was there less distance from the line if you were to draw a straight line? So this seems like they're kind of spread out a little bit. We've got this guy here and that guy there. And I'm going to go back and I'll graph the other one for you real quick. So we'll just do list 1 there, and we'll do zoom 9. Here's this one. So if we drew the straight line here, it seems like to me that that straight line would be, the points would be a lot closer, or a little bit closer at least, to that straight line. So I'm going to say that first version here, I'm going to say that waist size versus body fat is going to be more closely related. So the points, I'm going to say here, would be closer to a best fit line. Not by much, but by a little bit. We have another example here to look at, and this is kind of lumped in the same example. It's doing the same thing, but they've already given us a graph here. So let's take a look at number 4. This is a different set of data. We're talking about now human height in inches versus wingspan in inches. And we want to describe the graph. Well, it seems like as height goes up, so does the wingspan. We could also say that the points line up in a straight line. In other words, there seems to be a linear relationship. Now, not exactly, right? We're human beings, we have different heights and different wingspans, and they're not going to be a straight line. If we were robots, maybe. But there's some variation in human beings. That's okay. And so they don't all line up on a straight line. Some people might be a little taller, but their wingspan might be a little less. And some people, conversely, might be a little shorter, but have a larger wingspan. And that's all right. Do you think there is a relationship between height and wingspan? Yes. See above. And we've been kind of talking about it, right? Might be linear. We don't know if it is or not, but based on the data that we see here, it seems like there's a linear relationship. It doesn't curve, and it's not lumped in a circle or something like that. Using the graph, what is your best prediction for the wingspan of someone who is 6 feet tall? Someone who is 6 feet tall, we're going to have to multiply that by 12 to get inches, and I think that's 72 inches. So we want to predict the wingspan of that person. So 72, if we were to count off some tick marks here, now this is kind of tough, 1, 2, 3, 4, 5, so each one of these is going to be worth 1, so I think that's about a 72. What we want to do is we want to draw as perpendicular as a line as we can and parallel to this other y-axis, so we're going to draw that up. And then a best fit line would probably be maybe somewhere in here. Some of the data is below, some of it's above. This is definitely not perfect. And we actually want to go a little higher here with that line then. And then what we're going to do is we're going to draw this line over, again, as parallel as we can here and as perpendicular as we can be to the y-axis. So we'll see how this does, right? And it looks like maybe this is 71, 72, 73, 74, 75. So it looks like that might be their wingspan. Wing, I can spell here. Wingspan is 73 inches. That's a prediction. Doesn't mean that's actually going to happen. But you would predict their wingspan to be about 73 inches. Very close to that 72. So you may have heard that your wingspan should be about the same as your height. And it seems like here that would follow. If you listed 72 here for this one, that's fine too. It's hard if we don't have an exact line and make these exactly parallel and perpendicular. But I think a wingspan of 73 is appropriate.